Hey, welcome back to Buffalo Island Engineering. This is Austin again. Today I'm going to go through kind of a real life example of when you can use 3D scanning, how to take it from a concept to a scan to a CAD design, utilizing lots of different technologies as well as mesh modeling, things that do work, things that didn't work for me, how to manipulate that mesh within a CAD software. I'm not very good at meshes, but I was able to limp it along to make it work, and how to actually take that and turn it into a real physical part that's actually able to provide a benefit within. I did this whole project in just 2 days, so just a couple hours each evening, and was able to get something very functional and usable. To give you a little background as to why I'm doing this project, I recently got this used mountain bike for my daughter, but she's only 5 years old, so gripping this shifter and actually being able to rotate it is quite difficult for her, and especially doing it while riding is pretty much impossible. So I wanted to see if I could spend way too much time and effort rather than just letting her get strong and get used to it over time. I wanted to see if I could over-engineer it and make something that would make it a little bit easier for her as she learns to ride. First step here being removing the original handlebars, peeling the two rubber pieces, which fortunately came off pretty easily. I'm going to go ahead and get out and set up the RevoPoint Metro X 3D scanner. This is still something I'm trying to get the hang of, as you'll see. So my first trial was to go ahead and actually add marker location dots to the physical bike handle and shifter itself. And my hope there was I was going to be able to scan the bike handle and then build a matching part for it. But as I was trying to scan, it's still in a very early phase of the software, and you can tell it didn't work out. So I decided to take off the actual old grip piece and see if I could scan the inside of that, and then I would make a piece to match it. So with the Metro X in the laser scan settings, I'm actually able to scan a fairly dark object, which you're not able to do with some of the other just non-laser based scanners. So I was fairly impressed with this. Going through, you can mesh the model, isolate all the remote objects. And what I've kind of learned is that when using a 3D scanner is you don't actually try and create a part that you're going to exactly replicate. You're not going to take the scanner, you're not going to make an exact part, you're not going to just go ahead and print it. I have done that on occasion, but for a complex part like this, you're always going to have some holes. If you try and use the hole filling features, it's just going to give you kind of nonsensical data. So my recommendation for any 3D scanning type object is to go ahead and use it as reference geometry to build your new part off of. So here I'm just going through and cleaning up the model and deleting all the surfaces and faces that either are not part of the part or just poor scans, part of the turntable. Simplify the mesh a little bit to reduce the data. And then when I'm going to the actual mesh here, I make it as precise as possible so I can actually see it. And it's actually not a terrible view for still being new to 3D scanning. So here I went ahead and saved that. I think I did an OBJ for this one. And after I got the .obj, I import it into Fusion 360. And you do that by doing insert, then mesh, and you want to make sure that your unit type is selected appropriately. I do millimeters with my scanner, and I take reference measurements sometimes just to make sure that, okay, it's approximately 2 inches wide. Yeah, I know that if I measure it as 2.1, I'm probably using the right unit type here. So then I go ahead and orient the part in relation to the origin, and that makes it a lot easier for actually sketching on this part. So I try to get the center circled and everything aligned here. Then what I'm going to do next after I get this part oriented is I go to mesh, and there's actually a feature called create mesh section sketch. You'll see me clicking on in the top left there. And so what that does is lets you select the mesh part, and then you can click a plane from your origin or something else. You can drag it down the part, and basically you can create multiple sketches very, very easily. And those sketches are going to actually be used for my reference geometry that will actually be used to create the new part. So rather than trying to fix this scan and create a new part around this scan, I'm basically going to take this scan, I'm going to use it as a reference geometry, and I'm going to build the part I want to make around this same geometry. So that's what you're seeing me do here. I deleted the mesh, or actually I just hid the mesh so you can't see it. And that right there is honestly enough of a section where I can see it. If you need to adjust something, all you have to do is click on one of these and you can adjust it. You can hide them, you can make them visible, but this gives me enough of a reference to start building my own part around. So here I've gone ahead and I'm gonna basically hide all the sketches that are not relevant to the exact part I'm gonna be working on. So hit everything else. Now I'm going to actually hide the mesh, and I'm gonna show just that section sketch from that piece. So when you look at it, it's a little just kind of messy, but I'm gonna go ahead and use a spline tool and create my new component. It's gonna take a couple times. I always make the mistake of clicking the wrong button rather than clicking the check mark, and I usually delete my own splines, which is kind of frustrating. So here I'm going ahead and just basically replicating the exact geometry that we had in this bike handle, because I need this to match up with the mating part on the actual handlebars. So I don't need it to match everything exactly, especially on the exterior, but this is why I'm kind of going fast here. I'm just trying to create some form of sketch that I can revolve around the main part. So that's my revolved part, and that's my initial mesh. And you can see I'm pretty close to matching perfectly when I show both the mesh and my new revolved part. And this is where you can fine tune even your positioning for the mesh. I can go ahead and go back and edit my mesh and shift it around a little bit. And that, if I'm doing it in the timeline appropriately, that will update all the sketches appropriately. So then I can go back to my last sketch that I revolved. So the next thing I need to do is actually replicate the splines from the original handle. So I have a section sketch, and I'm just kind of looking at this. You could use calipers to validate this, but my scan actually turned out fairly well for this one. And I chose the sharpest feature. I'm not choosing all of them. I'm not choosing the little wavy sections. I'm choosing the right feature. And now if you look, I'm actually re-enabling the mesh to, again, engineer around the original part. I'm not doing this in such a way that I'm trying to use the mesh as it's the scan as the actual feature, but I'm using it as a reference geometry. So when I create a little rectangle, I can go ahead and easily extrude it out, take a look at that mesh, the scan, and see how far out it goes. Then I replicate it around the perimeter 8 times, around the same axes that I revolve the part around, so I know it's all very symmetrical. And now I have that part actually pretty darn close to the original mesh here. All right, this next part's a little tough to see, but if you look closely, there's that small orange line. That's another one of our section sketches from the original scan. And this is a keying feature on the bike. So basically it's a little notch on one section. So I was trying to make it symmetrical, trying to revolve it around the same axis, or make it reference the same revolving axis that the rest of the part is on. So rather than trying to create anything complicated, I just did a simple pie slice and cut out my actual revolved model, and then just added a couple little radii to it to mess it up. As you can see, sometimes I put in too large of a radius. Did a section analysis there so I could see it. And this is where you refine things. You say, oh, shoot, I cut through that a little bit too far. My simple method, I didn't want to make a bump out like they did in their original part. As you can see in the scan, they bumped that out a little bit. That's because they need to comply with even wall thickness when molding things. I didn't really have to do that because I was going to 3D print this. So I'm going ahead and just expanding everything a little bit, and then going back in the timeline and seeing if I fix that problem. If I see here, not quite there, let's just extend this out a little bit farther. That's the joy of parametric modeling, is you look at that, now I have the perfect cutout. I add a radius there, that's even gonna fix it more. And I don't have to worry about what was already cutting through. You know, it's perfect on the outside. I have a little bit of a thin wall there, but I'm okay with that, especially for this purpose. So at this point in time, I have a part that's pretty darn close to the original part. Obviously, I don't have the grip texture in there, but that's okay. I did a little more refinement here. But what I'm going to do next is actually I'm going to start building the features that I wanted to add to the original part. Remember, this whole exercise is not just to see if we can scan and model a part. That's part one. But part two is, can we scan, take that part, and turn it into something that we didn't have before, something that didn't exist before. So now I'm going to go ahead and actually start sketching that out. I'll be honest, I wasn't exactly sure what I was going for here. I wanted something that looked decent, but the design constraints that I had to consider were that I needed it to fit on a bike handlebar, and I needed it to not have pieces that my 5-year-old could get her fingers caught in. So I was trying to figure out some way to make a paddle that sat on top that wasn't going to absolutely, you know, catch her fingers, so if she fell, we weren't going to have a broken finger to deal with in an emergency room and an upset wife and upset daughter. So now that I had something I kind of liked as far as a shape that would work for this item, I went ahead and extruded it both directions. I turned it from a cut to extrude, and down in the operation style, rather than join, I actually did new body. And you'll see under the bodies, it created a new body once I actually go back in the timeline there and update it. But there's kind of a good reason behind this, is that when you extrude, if you joined it right away, it's very difficult to match that inside profile. So I actually went ahead and did new body and then used the combine features to use the original revolved feature to cut the first body. And then that left me with the top and bottom. And now I can go ahead and I can delete that bottom part, which now means we follow that bottom profile or that interior profile perfectly. And, you know, it's a pretty easy process. Every once in a while you have issues with the combine features where it, you know, it doesn't like the way the order of selection that I do. But you go ahead and either delete or even hide the interior part there. And then you can use your combined handle piece and the revolved portion of the handle and work on your blending and your radii. So I wanted this piece to be a little bit chunky to make sure that it didn't snap off. And you'll see I'm having a lot of issues with my radius here, and I didn't have that sharp of curves. I couldn't figure it out for a little while. But what ended up happening is I realized that the initial part was meeting, or the handle part was meeting the revolved section at a little bit too steep of an angle. So the nice thing about this is I can go back into the original sketch and I could say, okay, let's actually just drag that down. Let's make this a little bit of a more perpendicular entry point. And then that actually let me do a couple of the radii that I wanted to do. Sometimes you just kind of have to think outside the box and go back and change something that you shouldn't think would need to be changed. But the parametric model lets you go through and modify most of these things. And then you'll see in a couple points here that my tangents weren't right. I just kind of sketched this without spending a lot of time on it. And oftentimes I'll go through and I'll try and find the radii that work, and I'll just kind of do trial and error to get radii that work. But as far as I'm concerned, that's a part that is good enough for me. You know, I didn't know if this was going to work. This is my first time doing something like this, especially mating with another part with such tight tolerances. But now I just take that part, I go ahead and export it as a mesh, and I'm going to 3D print this guy. So then I go ahead and open my resin printing slicer. And for me, I actually use an ABS type resin. And when I import the part, there's a lot of different videos you can look at on orientation of the part. You never want things to be square to the build plate. You never want things to be too angular to the build plate. You want your visible surfaces or your important ones to be up, not with the all the support pieces touching it, because those will always leave a little bit of deformation there. I like doing really light supports, but high density. So many small supports. And then I always go through and manually add supports all around the edges where I need tight tolerances. This is a trick I learned from another YouTuber. I'll try and find him and maybe link him in the video. But that gives me nice square consistent edges. And again, it's really tiny light supports. Don't be worried about adding more supports. When I first got into resin printing, I'm like, man, that's a lot, but it's a minimal amount of resin. These resins don't cost a lot. You can afford the extra 30 cents of resin to actually get this printed. So I wanted to make sure that that second shelf that you see is actually fully supported, and it's kind of messy here, but that's what I really needed there. And then if you see that handle, we want to make sure the handle was supported as well. I'm going ahead and actually, I'm going to go ahead and slice this now. So I do a little bit of contrast blur, which helps smooth everything out. And then since I don't pay for this system, I get my nice 30-second delay before letting me slice. And this is actually sending it to the file. It's showing you layer by layer how it's going to print this object. And something I learned also is I have the layers on the very top before I click generate or send to files. And for some reason, I've had my printer stop in the middle of a print, and I think it might be because of where that layer is to start. So let's go ahead and get this on the printer and see what it looks like. So now we just go ahead and insert our USB where I save my file. Go ahead and click print and find the right file type. Click play. Yeah, that's it. We're getting it started.
All right, 4 hours, 37 minutes later, and we have completed what looks like a successful print. Most satisfying sound in the 3D printing world. Let's see if it actually comes off easily. Oh, that's pretty good. Oh, yeah.
So when I do resin printing, I'm using an ABS-like resin, not the generic brittle stuff they use during, for minifigure replication. I do about 5 minutes of wash time. I don't want it to get too soft by doing too much extra. Fortunately, this time my wash basin was really nice and clean. I'm finishing up a production run of little seat track guards from Mercedes Sprinter vans that we sell. And man, this came out really crisp and clean. There are a couple imperfections on the just where the supports held on, but also before you go ahead and cure the parts, make sure that they are completely dry. So I use a little compressed air, blow them off, get them fully dry. Some people even leave them out in the sun for a little while or let them, air dry as well. But for me, compressed air is good enough and a little bit faster. So 5 minutes wash, and I do 15 minutes of cure time. I'm not sure if that's the recommended amount. I couldn't find that anywhere. If you have suggestions, leave it in the comments down below. Now for a finish, I kind of wanted it to be a rubberized texture. And for this one, I actually just did a plasti dip because I had that sitting around, trying to get it to match to the other bike handle, the rubber bike handle parts as closely as possible. The plasti dip looked pretty darn good when it was done. But now that I'm making this video and we've had quite a few rides on it, it's actually starting to peel off because it's more of a temporary texture. That might be poor finishing on my side though. So getting it on, I had to align that last notch with the bike or with the shifter so it could actually rotate on there and actually grip it. So as you can see, it took me quite a while to get this on. I was worried about having to put a set screw in or some adhesive to hold it in place. But when I went to actually assemble it on the bike, it took a lot of extra strength and, as you can see, a plastic tool so I didn't damage it too badly to actually get this thing mounted. And then I slid the bike handle right back on the outside, and it fit pretty much perfectly. So my hands are obviously too big for this bike, but shifting worked well. Flicking back and forth, not a problem at all. You can see there's one little chip I made when I was doing my dry fit. When I was trying to get the thing back off, I had to use the plastic shims and still managed to chip it. So I was a little frustrated about that. But overall, to me, it looks like a professional part. It fit really well and looked clean and fit the setup. So we went ahead and took it out the next day to the mountains locally. This is my daughter's first mountain bike ride up in the mountains. New mountain bike for her. And she had a great time. And as you can tell with any mountain bike ride, it's not going to be complete without multiple stops when you're riding with a 2 or a 3-year-old on your bike and a 5-year-old on her own bike. It's not complete without a a full picnic after you've ridden for about 10 minutes. So the girls packed everything and it worked out great. It was a fantastic trip, and thanks for joining along in the journey, and we'll see you on the next one.